Before we get much further into this graphing unit, I want to go over all the names of the parent functions. Parent functions are basic equations which have a certain shape. And as we transform those shapes, as we stretch them or move them around, they'll still look a bit like the parent function that they came from. They'll just be different in some ways. So let's go through this list of parent functions. These are the 8 most common graphs that you'll be seeing and using. And we're starting off here with a square root function. And you guys know what a square root is, right? We have this equation, which is just y equals square root x. And the domain of this thing, you can see it clearly starts at 0, and it is exactly equal to 0. So we use a square bracket, and it goes out to infinity. And we always use a curvy parentheses with infinity because you cannot touch infinity. You are always going further and further and further, but you never get there. So the range, which is the y value, is also 0 to infinity, okay, where we touch the point 0. You can take the square root of 0, and that's just fine. There's no domain restriction there. But you see there's all this negative stuff that we can't do because you can't square root a negative number, so that is excluded from the domain and range. Okay, so moving on, we have here a cube root. That's the name of this function, and the equation is y equals the cubed root. Okay, the domain of this one is all the numbers. Okay, and likewise for the range, because you can take a cube root of a negative number, and there's nothing wrong with that. You can get positive and negative values, so that one goes on forever. Then right here we have a quadratic function. And quadratic functions you guys are used to dealing with a lot, actually. This is just the old y equals x squared type function, or a parabola. And you can see the domain here is negative infinity to infinity, but the range only goes from 0 to infinity, right? You cannot square something and get a negative number. We're not dealing with imaginaries here. You can't square a real number and get a negative number. So we are limited to the positive numbers. Okay. And this one right here is very, very simple. This is a linear function, and the parent of that looks like y equals x. Okay, the domain being all numbers, again, and likewise for the range. And then let's move on, find a few more. Okay, so this is an interesting one. This is the absolute value function. And we write it this way. You've probably seen it before, but if not, those are not parentheses, and they're not square brackets. They are straight lines on either side. That means you take the absolute value of it. So you cannot have a negative number of whatever's inside those straight lines. The domain is all numbers. But since we can't have negatives, the range goes from 0 to infinity. And then this one, I think it may be a while since you've seen this. This is an exponential function. And the equation for this looks something like this. It's e to the x. And maybe it's 2 to the x, or 3 to the x, or 5 to the x. But whatever it is, you have x in the exponent of the equation. That's why it's called an exponential. The domain is all numbers. You can see that from the graph. But the range, if you look close, you might think that the range goes from 0 to infinity, including 0, but it's not. We cannot actually get to the number 0. And you can play around on your calculator. Try putting in a bunch of numbers for x and see if you can ever get the result to be equal to 0. You can get close. You can get very small numbers, but you cannot actually get it to be equal to 0. So we have another domain limitation there, or range limitation, I should say. Okay, this one right here, you are familiar with by now. This is a rational function, okay? And it is something like this, 1 over x. And of course, we've been through the rationals unit by now, so you know there's lots of different rationals. We have many forms that this could be complicated by. You could have x minus 3 on the bottom. You could have x squared plus stuff on the bottom. But they're all types of rationals, and they fit under this umbrella of the parent function, 1 over x. So the domain of this is actually complicated. You see, we can have any y value going down to negative infinity and up to 0, but there's a horizontal asymptote right there, right in the middle at y equals 0. So you cannot touch that. We use the union sign to hop over it, and then we go to infinity. And my union sign looks messy, so let's just make that more clear. And then that's the same for the range. Okay, negative infinity to 0, and union 0 to infinity. Okay, and this last one is called cubic. It's a cubic function of the form y equals x cubed. Okay, and the domain on this one, like the cube root, is everything. Negative infinity to positive infinity, both for x and y.